Welcome back to Applied Algebra and Trigonometry. Today we're going to be talking about solving exponential and logarithmic equations. Today I'm going to be showing you three techniques for solving such equations. As you can see, I have the same equation written 3 times across this page, and I'm going to show you 3 different ways that you could solve the equation for x. Now first off, if we rewrite 8 with a base of 2. Why would I want to do that? Well, because I have a base of 2 on the opposite side of the equation. So if I rewrite 8 as 2 cubed, I have the same base. And the only way for 2 to the x to equal 2 cubed is if x equals 3. I'm done. All right, another way to do it, in column B here, is to convert from exponential to logarithmic format. So if I'm converting to a log is the exponent of that equation. So I have the log, x equals the log base 2 of 8, the argument. So when I'm reading this, I would say, what is the exponent of 2 that gives me 8? And the answer is 3. The third way to solve this equation is to take the natural log of both sides. I'm doing unto one side as I do unto the other. So I take the natural log of both sides, and because of the power rule, I can bring that exponent out front, making it an x exponent. Anyways, if you're into puns, you'll understand that one. All right, so I have x times the natural log of 2 equals the natural log of 8. Now, if I divide both sides by the natural log of 2, because I'm solving for x, I want to isolate it, I'm going to get x equals the natural log of 8 divided by the natural log of 2. And you can evaluate that in your calculator, and you will come up with x equals 3. Now, let's talk about what I did in each case. And let me make this a little bit smaller so you can still see it a bit. All right, so in the first place, the equation is in exponential form, right? Each of these, it's in exponential form. So leave it in exponential form in the first case and find a common base. A base that you can use to express each of the sides of the equation. And then just set the exponents equal. In other words, set them up as one exponent equals the other. You may have to solve a little bit. In this case, you didn't. As soon as you set the exponents equal, you had your solution. Sometimes it'll require a little bit more work, but that's not too hard if you're able to do that with the common base. Sometimes you won't be able to do that, so we have these other methods. So for this one, we're going to convert to logarithmic form. And then evaluate the log. And the third method I've shown you, to do that, you take the log of both sides, both of them. Solve for x. And evaluate. With the calculator if need be. If needed. So let's take a look at another equation with these 3 methods. All right, let's look at the equation 2 to the x plus 1 equals 7. Same equation in each of the 3 methods. And in each case, the expression x plus 1 is the entire exponent. All right? So, can we find a common base for that equation? And the answer is no. This method does not work with that equation. Let's try converting to the logarithmic. Convert this to a logarithm. It would be the log base 2 of 7 equals x plus 1. Can we solve for x there? Sure. Let's just subtract 1 from each side. So the log base 2 of 7 minus 1 equals x. Done. All right, what if we take the natural log of both sides? So I take the natural log of 2 to the x plus 1, and that should be equal to the natural log of 7. I again have a power that I can bring out front, so I have x plus 1 times the natural log of 2 equals the natural log of 7. All right, I am solving for the x. The x is still here within the parentheses, but at least I can get rid of my natural log of 2. It's multiplied by the expression that has my variable in it. I'm just going to divide both sides by the natural log of 2. And that leaves me with x plus 1 equals the natural log of 7 over the natural log of 2. I still need to isolate my x. I'm adding 1 to it over here, so I'm going to subtract 1 from both sides. X equals the natural log of 7 divided by the natural log of 2 minus 1. Oh, look at that. It looks like I got two different answers. One's in a log base 2, and this one's in a natural log. So what can I do about that? Well, if I convert using, there's my convert sign, my change of base formula, I can change that log base 2 into a natural log. The argument goes into the numerator. The base goes into the denominator. And now I can see that they're equivalent. The other way you could do this is to punch this into your calculator and see what you get in both cases. Remember that what you have here as answers in each case is the exact answer. And when you plug it into the calculator, you're probably going to get an approximate answer, as it will be in this case. So going back to the log base 2 of 7 minus 1 equals x, there's how you would enter it in your TI-89 calculator. Remember, you enter the argument, comma, and then the base. On your screen, it will look like this. And when you hit enter, it should return 2.8074. All right, that is the sequence for the log base 2 of 7. Then we need to finish the equation, which becomes 2.8074 minus 1 equals x, or x equals 1.8074. Here's the sequence on the TI-89 that will give you the answer to the equation that we have here in the third column. And once again, it will return to you 2.8074. And you're going to subtract 1 from it and get the same answer as in column 2, or rather column B, as I said. Let's work on some examples now. If you need to, you can stop the video, rewind, and go back through the different methods of solution. Right now, let's do example 1. Let's look at 2 times the base of 4 raised to the exponent of x minus 1, when that is equal to 17 to the x. All right, we have something that has exponents in it. We have an exponent of x up here, and, well, an x minus 1, but an x is in there. We have an exponent of x on the other side. Therefore, we have something that looks like an exponential equation, and in fact it is. Let's then Since it looks kind of like we've hit a dead end here, let's put it into logarithmic form by taking the natural log of both sides. Okay, so all of that is within the natural log. All of that is the argument right now of that side. And we're going to take the natural log of the other side. So 17 to the x becomes an argument. And now we're going to start applying the rules of logarithms. On the left side here, I have a product. I have 2 times 4 to the x minus 1. So I'm going to break that apart. I'm going to make that the natural log of 2 plus the natural log of 4 to the x minus 1. Okay, that's the first step on the left side. Let's take a step on the right side. While we're at it, I have a power here. I can use the power rule to bring it out. So x times the natural log of 17 is what I now have. Now let's see what we can do on the left side again. I'm going to leave the natural log of 2 where it is for the moment. But I do have a power in the second log here. I'm still adding this second term. But now I'm going to be adding the quantity x minus 1 times the natural log of 4. And on the other side I have x natural log of 17. Still looks kind of funny. What could I do? I have x minus 1 times this natural log of 4, a binomial times another term. So let's do a multiplication here. Let's multiply each of those terms by the natural log of 4. So I would get x times the natural log of 4 minus 1 times the natural log of 4, or just the natural log of 4, equals x times the natural log of 17. All right, looking at this now, I have an x term, or a term with x in it, and a term with x in it on the other side. I'm trying to solve, maybe I should have made that more apparent up here. I'm solving for x. I want to isolate my x's away from everything else, and I already have just an x term on the right-hand side. So I'm going to subtract this x term, x natural log of 4, on the left-hand side, and I have x times the natural log of 17 minus x times the natural log of 4 on the right-hand side. Still need to isolate that x. But there's an x times something in the first term and an x times something in the second term on this right-hand side. So I have a common factor. I have a common factor of x. So I can factor out that common factor now. They're on the same side. All right, and I'm left with x times all of that, which means I can divide the right-hand side by the natural log of 17 minus the natural log of 4. But if I do it unto one side, I must do it unto the other, dividing both sides by the natural log of 17 minus the natural log of 4. So on the right-hand side, those divide out to be leaving me 1 times x. So I have my x isolated, and it is equal to the natural log of 2 minus the natural log of 4 over the natural log of 17 minus the natural log of 4. That is my final exact answer, but we can put it into the calculator to get an approximate answer, and then we can check that approximate answer much more easily than putting that whole expression back in for every x in our original equation. So let's do that in the second video in today's series. See me there.